Hey, I am Maris and I'm an Agile coach and we are at Agile Tour Singapore 2015. Hey,
Hi.
good morning.
Good morning.
So why we are here and what's about? Can you tell about yourself?
So I'm Kiro Harada, Agile coach or consultant or modeling people, whatever. So I came here to talk about TDD or ATDD on hardware.
That's fantastic. Yeah. So even like yesterday I attended your session. This is awesome. So can you give a little bit detailed about the topic?
Yeah, the topic is about so since we're software world, we created the test-related techniques in place for a long time. First with TDD, and then become a BDD, behavior-driven, and also acceptance-driven. That helps the software developer create a software, or should I say, a software developer can understand or your software is working or not, and then it helps our software development process. Then we thought, why not with hardware? So we try creating a hardware that is a test-first basis. So that's what I presented this time.
Fantastic. And also I saw like testing hardware by hardware, right?
Yeah, right.
And I saw the simulation which you with some hardware. Can you explain about that? Like how we can test the hardware by hardware?
Okay, so for the testing purpose, for demonstration purpose, we use Arduino, the popular single board computer that runs a very simple language. So first, basically, Arduino machine is getting some input, and then as a result of input, we get out some output. So then we first create a small Arduino, also another Arduino machine, that puts some input to another Arduino, and then it detect the output from that target board, and then make sure the output is as expected. So it's like a more TDD test code for hardware.
So and also you mentioned like TDD and BDD and ATDD.
Yeah.
So shall we implement that in hardware, BDD?
Since the hardware, we cannot actually get into the inside the CPU. So it's basically a black box testing from outside. So it's only testing the outside behavior, so it's more like a BDD, not testing the inside.
And also I heard like you mentioned about the cars, right? So the how it evolves and how the for example you mentioned about the choke. Right? Can you explain about that, like?
So for the hardware thing, especially for machinery like engines, people need to check if it's working or not. So since I think you'll be old enough you remember the old engines, you have to manually start it, or even a car with starters, you have to choke to control the density of the fuel.
Yeah.
And then you check the air, you check the temperature, and then after you turn on, you have to listen to the engine, it is working properly. Otherwise, you have to stop it and fix it.
Yeah.
But the recent car, how do you start the engine?
Sometimes like the modern car, start the car, it will start.
Yeah, it just push the button.
Yeah.
So it detects all the testing. Okay, the car is or engine in good condition. The battery is high enough. You control the fuel and also other parameters. It is all tested and controlled by software. So I think it kind of testing is already in there.
Yeah. So and how you see the TDD testing in software and hardware? How you see the difference between them, and what are the challenges you are seeing, especially when you test hardware?
So one of the things I started using it, or I actually to develop a mixer, we use a TDD related software. Software testing for hardware to develop hardware. Since in developing hardware part of it, it is very hard to find out they're making correct things or not. Since hardware need all other way around to test it is working or not. As a result, turnaround time for hardware design improvement is so slow. So I like to make it faster or lead time to fix the problem, just like TDD did to make the latency of each increment, working software increment shorter. So I can do the similar thing in hardware. And then unfortunately with our cases, all the input-output digital audio signal. So it is very easy target for us to implement in the hardware testing harness to test the hardware.
It's interesting to know.
Yeah.
Yeah. And also you talked about the scaling, right? So how you feel about like scaling in hardware?
Scaling hardware is a kind of easy thing. So manufacturing, we can create the same device again and again. And also you can make sure that the other factory can create the same quality hardware again and again. So it is how mass manufacturing worked. But recently, cars are no longer identical to each other.
Yeah.
You know what I mean? Yeah. It's have a different color, different tires, different engines, different fabric on the seat, different car navigation, different audio, whatever. There are so
Totally
many
different,
kinds of them.
Yeah.
So then our hardware manufacturing is changing the meaning a little bit. We are creating so huge variations with minimum amount, very cost effectively. So it's not really like a mass production now.
Fantastic. And the last one, you mentioned about refactoring in your TDD in the hardware. So what do you mean by refactoring in the hardware?
So yeah, I think it's a pretty good one. So since I didn't do the same refactoring technique in the demonstration right now, but we have Intel Edison. It's a smaller, faster CPU machine compared to Arduino, but it has a compatible interface with Arduino. So if we need a much higher speed and higher processing time, I can keep the test harnesses the same, but replace the target hardware from Arduino to Edison. It is possible. So yeah, okay, replacing the platform is a big deal, but having a hardware test there, we can refactor that way too.
Fantastic.
Yeah, we have the same behavior outside still.
That's fantastic.
Yeah, that's become.
Thanks, Kiro. Today we learned a lot from you about the hardware and TDD, ATD. A lot of things we learned. Do you want to say something else?
I think it's fun to play with the hardware, and then I personally believe that there's no software engineer, hardware engineer anymore. We are engineer. We love to hack and create something new and innovative. I'd like to join,
Yeah, sure.
creating that stuff together. Thank you very much.
Thank you. Thanks, Kiro.
Thank you.